Hi, so today we're going to experiment a bit with gear motors and how to get a sort of shredder and a bit about speed and torque and gears on the way. Let's get started. That's a pretty quick intro anyway. Let's get started. So first one is a drive motor. It's a drive motor. I can't use a washing machine motor. Probably break the gear to a tremendous power. But it's a bit of a smaller one, like so I got from the printer in my last video. If you have watched it, please watch and please subscribe and click notifications so you don't miss a video. Anyway, back to the video. This is a DC motor, a 12 volt DC motor. When you have 12 volt electromagnetic current going through here, the speed and torque are tremendously high, nearly unstoppable. And it's better still, if you get this gear, just in here, it becomes unstoppable because the speed is reduced and the torque is increased. As the simple formula shows. The bigger the gear, if the gear is bigger than the smaller one, the bigger the gear than the smaller one, the more torque there is and the less the speed is, as there is this ratio. Correction. The bigger this gear is, the bigger the gear, so if one is the same size, the lower the speed on it, the higher the torque, as the simple formula shows. You can use the equation to determine the torque. The number of teeth on the first gear is as to the number of teeth on the second gear. Which means the torque on the first gear is as to the torque on the second gear. Let me give you an example. So yes, it's an example, it's quite impractical. So let's say we have a gear ratio of 5 is to 20. So we have 5 teeth on the first gear and 20 teeth on the second. In real life you'd have way more than this, but as I said, this is an example. Now, if I connect if I apply, say, 10 Newton meters of torque on the gear with 5 teeth, on the second one, we will have 4 times more torque because 20 is 4 times more than 5. So 10 Newton meters times 4 equals 40 Newton meters. And let's say we're at a speed of 200 RPM on the gear with 5 teeth. If the torque goes up, the speed goes down, and vice versa. If the torque goes down, the speed goes up in gear systems, and there's losses too. Divided by 4, because the speed decreases, equals 50 RPM. This means that the torque is increased by 4 times, while the speed has decreased by 4 times. Now let's do the other way around. Let's say we're at 5 is to 20 again, and instead we apply the speed and the mechanical energy on the gear 20 teeth. So now let's do some more maths. 10 Newton meters is divided by 4 because the number of teeth on the other one is lower than this one, so the torque is lower and the speed is higher. Divided by 4 is 2.5 Newton meters. What's 200 RPM? Was 200 RPM times 4 because the gear ratio, because 5 is 4 times less than 20 times 4 because it's vice versa, equals 800 RPM. And there we have it, as I will show you. And for you watch, the practical is much more different than in theory because, as I said, this is an example. Here you have way more than 20. Way more, and here I have more than 5 teeth. So let's see here, if I turn this quite fast, speed is very low, but sure, very, very high. So if I turn it from here, speed is extremely high, it's really high here, way higher than this one. But it's easy to stop, because of the torque, as you're seeing. Great, isn't it? Now on to the practical. Let's plug this motor in the main, and yes, it has a power supply, or else this motor will block on 12 volts. This power supply is an adjustable 3 volt to 12 volt power supply. The 12 volt is 16 volts. Take up the voltage higher than this maximum. So let's wire it. On auto switch. See if we have a clear. So I go to the 7. fired up. And I love to supervise something because yes, it's very dangerous to me. The motor turn, and I see it turn, and that makes me turn. Now it's just somewhere I have to adjust the speed. Battery nearly dead on discharge, so what you some junky turning batteries which are nearly discharged and nearly dead. Let's use them. Okay, the batteries are junky, but they still work, as you're going to see. And observe the motor. Very carefully. There's no gearbox over here. This thing is very fast. But it's not slow because the voltage is too high. Low. The gear back here. First, battery power. See it? It turns. Slow. It's a bit higher. Very low, but a bit higher because very efficient assist. And I think it's nearly impossible to rotate the other direction. And the better news is that with this, you can make a generator to power the bulbs. And also you can plug this in the gearbox system, which produces higher voltage. And once to a hand crank like this, you can have this shaft, and you put it in here. And you crank away. It's a bit hard because it's not very easy. Now put in the washing machine motor like that, you see, and I crank away. And I get out for the generating 30 volts. But the current is really low and the can be shorted. And I've got quite a practical. And if you want, I want to show you how to make a generator out of this one without the gearbox. It's really more effective and deliver much higher current than 1 amp. Like this, as you're seeing. I'm gonna crank it now. Watch. Speed is lower, granted, but it can deliver way more current. Much higher current. And it's pretty practical too. Unlike the washing machine motor. So as you can see, you can turn constantly like that. And you see, is until the little chuck fails. That would have put it where I have to tie it really tightly. Anyway, back to the video scope. So now my point is that I discover this shaft from the gearbox with this shredder. This shredder. Well, it's a gearbox from an old printer. What's it to do? Anyway, let's go. not directly in the main, or if the motor would blow up. But it's an adequate particle like this one. Okay, got that. A 12 volt adjustable voltage power supply. 3 volt, 5 volt, 3 volt, 4.5 volt, 6 volt, 7.5 volt, 9 volt, and 12 volt. Good enough for us. Let's plug it in. And also plug it in. And put the paper in the... See, shred the paper. Because the shredder is for satisfaction. But hey, it's working. See? It's crafted by the tremendous torque of the gears. Being drawn by the shredder. Try not to be so like... I think the current runs quite a bit. Store it. Current runs a lot. Store it. Fault to the gear system. Let's shred it. Let's put it in here and shred. Let's grab the octopus here. Shred, and it works! Very good. Well, it's terrible for a shredder, but it's good enough for demonstration purposes and for this kind of thing. But hey, at least it works. Good enough. I realize it's much stronger motors, but it's a high demonstration.